going to be fun. We'll see. All right, parts of a circle. So you said circumference. Circumference is the distance around the circle, so I'm going to put it on the edge. Circumference. And it goes all the way around. I'm going to say C is equal to, anyone know what the circumference is equal to? Huh. Something with pi. It's a measurement, so it's something with pi. Nope. 2 pi r. R is the radius. Or, what's 2 times the radius? Diameter. Are we sleepy or are we just rusty? Rusty? Okay. Okay, or both. I didn't say anything else. Okay, so the circumference is the distance. It's like the what of a shape? Starts with a P. Perimeter. It's the perimeter of a circle. Why is it called something different? What's the difference between a circle and like regular other shapes? Yeah. Has no sides. So we have to use, whenever we have something that is circular shape or round shape, odds are we're going to have pi involved. Does pi ever end? No. Yeah. Same, right? I'm quite indecisive as well. Okay. I had a hard time. I went out to dinner last night. This shouldn't be in this video. I went out to dinner last night. I'm like, I really don't want to decide what I want to eat, so someone else make the choice for me. Yes. I got the catch of the day. Yeah. Okay. We have 2 variables, radius and diameter. So I'm going to do the radius. How should I draw the radius? What is the radius? No, I don't like that. It starts from the center point and it goes to it's a segment from the center to a point on the circle. That's what I wanted to hear, but that's okay. But you knew how to like describe it. You had a feeling what it was, hopefully. That's okay. Okay. So I'm using blue. Your colors do not have to match mine. I'm going to use pink for my radius. I'm trying to debate whether or not to highlight the segment. What do you guys think? I should? Okay. Thanks for telling me. I wouldn't highlight the whole distance around the circle because that's a lot. Okay. I mean, you can if you want. There's radius. What else do we have? We have D, diameter. How would I draw in the diameter? How is it different from the radius? It's a segment that goes all the way from one endpoint to the other endpoint of the circle, and it goes through the center point. So starting somewhere else. Yeah. Weekly online? Yes. All right, you want to go all the way through your circle. I know it's hard to see because my picture is so big. I made a mistake of making this circle very large. It is a very large circle. This is the first time that I'm doing this, like where we're doing it together, and I like it. No, this is the first year that I'm doing this like as a class, whereas normally I make you draw your circle. I know. You're welcome. This is the diameter. So the diameter is 2 times the radius. Pick another color, highlight it. I'm going to highlight this one, orange. And then just like before, we're going to highlight the whole thing. So these are the things that are special. So special. Diameter, radius. Highlight in the formula D. Highlighting it the same color. Is there anything else that we already know? Atia, what's up? What's the definition? It is a segment that connects the center to a point on the circle. I like that. I like that you're asking that question. Thank you. No, I figured you had a question. That's why I said, what's up? What was my question? I forgot it. Oh, what else do you know about the circle? Anything? Do you know another formula? We have the circumference. What else? Area. So area is the space that takes up inside the circle. So go ahead and write area. We're going to use a highlighter for this. That's an R. I made it capital. I'll make it lowercase. Okay. Area is the space inside the circle. Don't highlight just yet the whole area. I'm going to sketch through it, but I want to finish drawing. Area, I think Issa told me the formula for area by accident. Area equals pi r squared. Pi r squared. I have a joke for that. You want to hear it? Okay. My joke is, what's the formula for the area of a circle? You guys tell me it. Okay, let's try this again. Hey guys, what's the formula for the area of a circle? No, pi r squared. Say that. Okay, let's try it again. One more time from the top. Hey, what's the area of a circle? Pies aren't squares, they're circles. Thanks. Hilarious, right? Okay. You're welcome. Hey, I didn't tell that joke in any of my other classes. You guys got the joke, so be grateful. You're welcome. You're special. Okay. Anyone know another segment? This is where we got my other classes and we had to freeze a little bit. So I'm asking you, is there anything else that we know? No. Okay. So look at the back and you tell me one of these and we'll draw it. Okay. What's one that we have not listed? Tell me a segment. So not the angles, not the arcs. The words that you don't know. Huh? A chord. So I'm going to tell you a diameter is a special chord. A chord is a segment that connects 2 points on the circle, but it does not have to go through the center. Yeah, Preston. So the formulas? Yeah, I'll stay right here. I'm going to draw in my chord. You draw in your chord wherever you want. It really doesn't matter. I'm going to put it right here. Okay. So endpoint here, a chord. So right chord. Chords are special, but we're not going to highlight them. It's fine. We're just highlighting the segments that use the formulas. Okay, give me another one. A secant. Secant. Okay, so I love that you said secant right after chord because a secant is an extension chord. It's a chord that goes outside the circle. Okay? So it's a chord that goes outside the circle. So I'm going to draw another chord. Let's go from the radius and let's go outside. Okay? So this is what it makes when you go outside your circle. So this part inside is the chord part. This part outside, the whole thing would be the secant. And a secant can be either a line or a segment. So you can make this into a line. But it could also be a segment. Ooh, I am not labeling any of my points. I want to go back and do that. But we can do that at the end. So go ahead and make your point where it intersects the circle. Okay, I think there's one more. Well, I think you've seen it before, right? So we did the chord, we did the diameter, we did the secant. What's the next one? Tangent. So tangent, when you go off on tangents, you have one thing in common of what you're saying. So I like to think of a tangent like I go off on tangents all the time. So find a point. Find a point on your circle. Let's go from the chord. And there is only one point in common between the tangent and the circle itself. And that point is called the point of tangency. So that's where they're going to intersect. We are going to talk about tangents all day. We're focusing on tangents today. So I have to watch for the hole punch. So I went like around it. Pretend that line goes all the way through. So this is the tangent. Turn in my circle. And right there, that's the point of tangency. That's a Y. Point of tangency. Okay, cool. Did we get all of them? We got our secant, we got our chord, we got our tangent, we got our point of tangency. You know where the center is. The center is right there. So if we want to label our center, we can. Yeah, why not? Okay, let's go back in. I want to double check. So I'm going to look on my vocab sheet and make sure that I got everything. I have the center of the radius of the chord, of the diameter, of the secant, of the tangent points of tangency. The rest of them are angles and arcs. So that's where we need to label our vertices. Do you see how everything's labeled on the back? That's what we're going to do. Okay. What do you want to call our center? What point? A. Okay. Do we want to just go alphabetically? Okay. So finish up A. This is B, C, D, E, E, F, G. Do I have any other points? So I'm just going A, B, and then all the way around. I just went all the way to G. Chord. E, F, and then the chord is right there. Okay, so let's go over central angles versus inscribed angles. So we're not going to talk about those too much until we get to them. Just like the rest of these guys, we're going to focus on tangents and the point of tangencies, and then radii. So we're going to use that stuff, and I think diameters come into play. But a central angle, yeah, Preston. It does say the point of tangency. That is correct. So we're going to focus on the central angle. If you had to take a guess, what do you think? Where do you think the central angle is? How would you describe it to someone? It has the vertex at the center. So looking at this, find where the center is and find a central angle. There's only 3 of them. Yeah. What do you think? GAB, I'm fine with that. So this angle, let's call this the central angle. Central angle. Whoop, whoop, indeed. Okay, inscribed angle. We only have one case of inscribed angle, and that is where the center is not, where the vertex is not the center, but the vertex is on the circle. So go ahead and find where the vertex is on the circle. That would be B. So it would be A, B, C. That is the inscribed angle. And really, we really should like extend it. Let's go ahead and draw another central angle. Why not? I'm going to go from the diameter from D. I am changing it. I'm sorry. Well, I'm not really. I'm going to be honest. I'm not sorry. Sorry, not sorry. We're going to add another central angle or inscribed angle, because honestly, for an inscribed angle, you really should extend all the way through. So this guy is inscribed. That's not to say that this is not an inscribed angle. It just doesn't go all the way through. Okay. Arcs. So we got minor arc, major arc, and semicircle. Those are all things. Any guesses as to what is the difference between, I'll turn it, difference between those three things? Yeah, what do you think? Yeah, so the semicircle would be what? Semi means half. It'd be half. So the diameter is its endpoints. That's the semicircle. We can go over that one first. Before I do that, I really do want to label that one. So what comes after G? A, B, C, D, E, F, G, H. Right there. Okay, let's go ahead. Semicircle is an arc that is half of the circle. That is equal to 180 degrees. So we're going to write that down here. Semicircle. It's an arc that is equal to 180 degrees. So an example of that would be what? So here's where we're going to get into some fun things. Arcs have an arc literally as the hat. Anything that is 180 degrees or greater, you have to have 3 vertices. Otherwise, you don't know which direction you're going. You have to have 3 points, I should say, 3 points. So we know that in order for it to be a semicircle, we should start and end at which 2 points? Where's the half? The diameter. So we should start and end with the diameter. Yes, no, maybe? Okay. So which way do you want to go? Do you want to go towards C, or do you want to go towards E? C. Okay, so we're going to do this semicircle. That's why, listen, that's why we need 3 vertices. We need 3 vertices to say the direction of it. So I'm going C, D, C, G. Or you can name it D, B, G. Those mean the same semicircle, same arc. Questions on that? Do you care? DCG or DBG? Okay. You said it. And then you put an arc. You put a hat above it. So nice, right? Okay. So, minor, I think of a minor person, like a minor, someone that is a minor. They are less than, they are younger than 18. You're a minor. I am a non-minor. I am an adult. So I'm more than 18. Okay. Minor arcs, I think of it as being less than 180. Oh, do you see it? Always mention. Okay. So for minor arcs, they can be anything less than 180. You always name them with 2 endpoints. So which arc do you want to go for? Yeah. Nope. You gave me 3 vertices, so I don't like that. GB? GB would work. FG, if you wanted to name that one, you could do FG. How about we do FG? Because that has 3, but we're skipping one. Or you could even do BE. BE is less than 180 because I'm looking at it. E comes before where the invisible diameter is. So any of those would work. I'm going to do FG. Because I'm only naming it with 2 vertices, 2 points, I know that it's going to be whatever the arc is that is less than 180. So I'm going to show you looking at it. Let's name the same arc, but let's go the other direction so that it's more than 180 for the major arc. Okay, so FG, do we all agree that's small? That's less than half the circle. If I name it the other way, so FDG or even FEG, that would be the other way. That's the major arc. Okay, so let's do that one. Major arc. Arc greater than 180. It can vote. Right? Minors can't vote. Majors can. Major arc greater than 180. We said I want to use the same vertices, but I want to have a point in the middle. So it literally does not matter which one. You could do FE, FB, FC, but you have to have something in the middle. So I'm going to go FE. It does not have to be the first one.